So to give some context, this is our overall robo-attic Thermadrone system. On the left, we have these blue boxes, which represent the diagnostics portion. These orange boxes represent the retrofit portion, and these yellow boxes represent the M&V, or measurement and verification portion. So the Thermadrone parts kind of sandwich the robo-attic part in the middle here. And this demo will focus on the diagnostics and the M&V portion. So this is what the homepage looks like. As you can see, we've done many different data captures covering some single and multifamily residential homes. So first we have the Corona building, which is from Southern California. Next we have Veracruz, which is from Central California. Santa Fe, New Mexico. Craigmont, which is around Berkeley, and Queens, New York. And so for the first part of the demo, we'll be showcasing the Craigmont dataset. So how the data was collected was we flew across Craigmont Avenue and captured 10 to 20 houses in the neighborhood. And so our interactive tool spatially locates these drone captured IR and RGB images on a map like this. So all of the pictures of the same house are of the same color. We can click on this checkbox to show the arrows to show which way they're pointing to, so you can see which house each color represents. And then we can also see thermal overlay just to see some side views of all the houses. So when I click anywhere on the image, like let's say here, we can see the thermal and RGB images for that house. So for this one, there seems to be a relatively smaller temperature difference between the attic portion and the rest of the house. But let's say if we go for this one, then we can see there is there's a bigger temperature difference between the attic portion and the rest of the house, indicating relatively better attic insulation. So this is a qualitative diagnostic. It's not anything definitive, but it definitely gives us an idea. We can also export this to other tools such as like DJI or FLIR to quantitatively figure out the temperature difference. So this is a really good customer acquisition tool to quickly diagnose and identify like attics in most need of retrofits. So back to our homepage, the next dataset we'll be analyzing is Santa Fe. So currently how it would work is engineers would go in with a handheld FLIR camera to take photos of the before and after. The problem with that is that it's pretty hard to see what corresponds to what, and also when they do that, they usually don't cover every square inch. But now our method kind of automates that. You can see a panorama here. This is actually of the DOE weatherization lab from Santa Fe. And we have software to automatically stitch this together. In this case, it was 4 RGB images that we took from our drone captures. And so to do a pre and post comparison, you would do 2 flights. In this case, the first flight is partial insulation, and the second would be fully insulated. So if I click on the panorama like here, then we can see a pre and post retrofit comparison. So normally you'd have to wait like 1 to 2 years to see your utility bills to make sure that it was all done correctly, but now we can catch like any small flaws. And this is a really good like quality assurance or control tool, so the customers can just like ask the contractor to redo any flaws that they catch. So the next building we're going to show is Veracruz. So I can click through here. So for the Veracruz dataset, we took 2 drone captures, one before the retrofit and one after. In this case, it was a retrofit on the windows. So if I click like here, then we can see the before and after for these 2 windows. Next, I can show the Corona dataset. So for this dataset, there's not necessarily a before and after, which just goes to show that this tool can also be used to just compare 2 sets of images. On the left, we have the building being heated, and on the right, we have pressurized. And once again, I can click anywhere on this panorama, and it will bring up the images from both flight paths. So for here, we can use the slider scale to change the temperature scale. And then I can also superimpose this thermal image on the panorama. So I can just click this button, and now I'm going to choose 4 correspondences. So I'm going to choose the corners of the window. And now once I've chosen all the correspondences, this superimpose button will be there. And I can click on that and wait a little bit. And now we can see the result superimposed on the panorama. And then lastly, we can showcase the Queen's data. So for the Queen's, we only had 1 capture, but we can still use our same system to just click on any point on the panorama, and then we can see the thermal image corresponding to where we clicked. In this case, there's only 1 data set that was captured, so there's no comparison, they're just the same image.